Here we go. So we're going to differentiate each function with respect to x. If you look ahead, all of these have an input of x. Nope, not down here, so we'll worry about that when we get there. I'm trying real hard not to do any real explanation other than what I'm doing. You can watch, I suppose, the lesson videos for that. Okay, so the derivative of y equals 5 with respect to x. The derivative of a constant is 0, so that's pretty easy. Number 2, 5x to the 18th. Our best notation is f prime of x is going to be 18 times 5. We'll figure out what that is, times x to the 17th. So that's 50 plus 40, 90, x to the 17th. Why don't we use dy dx? The derivative of 4x to the 5th is 20x to the 4th, and the derivative of x is 1. I suppose it's early on here if you're doing these, but gosh, these seem easy. 4 times 4 is 16x cubed. Derivative of negative 5x is negative 5, and minus 0. We won't write minus 0. Oh, good. Something that might be useful. So the derivative of 3x to the 5/4 is going to be 15/4 x to the 1/4. Just subtract 1 from the exponent. And let's go ahead and rewrite that. So 15 times the 4th root of x all over 4. We always want to rewrite those. Practice rearranging. So what goes on here? The derivative of 5/4 x to the 2/3 is 5/4 times 2/3, 10/12. I should have simplified. Divide out at 2. So 5/6. And then x to the negative 1/3. Don't leave it like that. That's going to be 5 over 6 times the cube root of x. Let's see. Y equals negative 4x to the negative 5, which is going to have a derivative 20x to the negative 6. So we'll rewrite that 20 over x to the 6th. So you can just think of this as 3 times x to the negative 3rd. So dy dx is going to be negative 9 over x to the 4th. You should be able to do that without actually writing out 3x to the negative 3. So the derivative of x to the 2/3 is 2/3 x to the negative 1/3. And let's go ahead and rewrite that much prettier. 2 over 3 times the cube root of x. That's a 1/4 power, so we'll go ahead and try to do that without rewriting. And so 1/4 times negative 2 is going to be negative 1/2. And then that's going to be x to the power 1/4 minus 1 is negative 3/4. So that'll be a 4th root of x cubed in the denominator. Alright. Ooh, this should be relatively straightforward. The derivative of 2/3 x to the 4th is 8/3 x cubed. The derivative of 5x is 5. And the derivative of negative x to the negative 3 is going to be positive 3x to the negative 4. So we might as well rewrite that 3 over x to the 4th. Alright, pretty straight power rule stuff here. The derivative of negative 1/2 x to the 4th is going to be negative 2x cubed. And then plus 5/3 times 3 is 5x to the power, what is that? Minus 1 is 2/3. So the cube root of x squared. and then the derivative of 2x is 2. So a little bit different instructions. Differentiate each function with respect to the given variable. So number 13, I suppose we're supposed to take the derivative of y with respect to r. So let's make sure we write dy dr. And that just means we treat r, well, maybe not just, but that means we're going to treat r like we normally do x. So negative 15 r to the fourth, and 5r squared has a derivative of 10r to the first power. So now we're just going to write f prime of s instead of f prime of x. The derivative of, let's see, that's s to the negative second. So we're going to have a coefficient of 6, s to the negative 3. So we'll write over s cubed. And then let's see, this second term is 4 over s to the fourth. So 4s to the negative fourth. So that's going to be plus 16. And s to the negative fourth, subtract 1 from the exponent. S to the negative fifth, so s to the fifth in the denominator. Ooh, these are getting rough. So f prime of x is 2/3 times 3/2, coefficient of 1, and then x to the 1/2. So we'll write that as square root of x. And then, so minus 3/4 times 3/5 is 9 over 20. And looks like we're going to have some x's in the denominator. 3/5 minus 1 is going to be negative 2/5. And so that's 5th root. It's on 5 of x squared down there. Can we keep track of this? Well, I suppose the one thing to recognize is that the square root of 2 is a constant. So the derivative of a constant times a function is that constant times the derivative of that function. And let's see. Maybe we rewrite this. Let's get rid of our prime. So that's the square root of 2 times s to the 1/3 plus the square root of 2 times s to the 1/5. And so that's going to be root 2 over 3 as our coefficient, and s to the negative 2/3. So the cube root of s squared. And then plus, so root 2 over 5. And subtract 1, s to the negative 4/5 is going to be the 5th root of s to the 4th. Alright, I think that's it. Oh man, a little bit more. Now I know how you guys feel. Differentiate each function with respect to x. Problems may contain constants a, b, and c. So, okay, so y equals 5 times c, that's 5 times some number. That's actually a pretty easy derivative. The derivative of a constant is 0. So 5 times 1, 5 times 10, doesn't really matter what 5c is, but 5c is a number. And, okay, so this is going to get a little bit weird. 4a counts as a constant, b counts as a constant, 3c counts as a constant, 3a counts as a constant. So, I guess we'll just keep doing what we've been doing. Okay, so dy dx is going to be, well, a constant 4a times our exponent 3a is 12a squared, and then x to the power 3a minus 1, which we can't simplify because we don't know what a is. And then 3c times b, so we'll write 3bc, x to the power 3c minus 1. Well, hopefully they match these answers.